This is a tutorial on how to connect a Shiny application to an API server. We're starting with a completely new Python Shiny application. We're initializing it with the package manager UV. Change directory into the new folder that you just created. Use UV add Shiny. Initialize the virtual environment and start the editor that you want. So I'm using source.venv/bin/activate to run the virtual environment. The editor I'm using is the free editor called Positron. I'm going to rename the main.py that was automatically created into app.py. I'm going to collapse the lower terminal for now, as well as the left sidebar. So I can just focus on this one file. I'm using the standard Python import statement from Shiny, import app and UI. I'm going to instantiate the Shiny app. We'll start building out the UI portion with the UI component from Shiny. So we'll call it a variable, app_UI. And then we're going to set it to UI.page_fluid. And within the page_fluid, we'll set up an H2. So this is the HTML heading 2, and we'll pass it a string, which will be Shiny text analyzer. We'll set up a text input box. So UI dot, and Shiny comes with a bunch of text input areas. So we'll use the input text area from Shiny. We're creating a multi-line text input box. The first value text is the input ID. This is the internal name of the widget. Shiny uses that name so we can access the user's input later in the server. The second value, enter text, is the label. That is the text that the user actually sees on the page. The rows equal controls how the text boxed is. We're creating the app server, which is the logic of the application. We have three objects here. The first is input. This lets us access the values entered by the user. So if someone types into our text box with the ID text, which we just created, we can read that value using input.text. The output is used to send results back to the page. Anything we want the user to see, text, tables, plots, messages, will go through outputs. We're next creating a function called result. This is an output because we're using the output decorator. The @render.text line tells Shiny that this output is going to be displayed as plain text. I need to import render from Shiny. We currently have a placeholder text. We're going to replace this with a function to pull data from our server. The app instantiation will assemble the program. Up until this point, we have two separate pieces. First, the app_UI contains everything related to the page layout, the title, text box, buttons, outputs, and anything the user sees. The second piece, app_server, contains the logic, how the app responds when the users type, click, or interact. We named our function result, and we're going to look at how this can connect to the user interface and the server logic. We have the UI.input text area. We now need to create a UI output text verbatim, and we're going to pass it the result. But first, let's create an input button. We want to create a clickable button on the page. There are two main parts. The first is the analyze button, is the button ID. So analyze_button is the ID. And this is the internal name Shiny is going to use in the server code. It allows us to detect when the button has been pressed. The second part is analyze, is the label shown to the user. So on the screen, you can see that when the app runs, you see the button with the label analyze, but the program refers to it internally as analyze underscore BTN. In Shiny, we have a system of IDs. So this output underscore text underscore verbatim, it accepts the output ID, which is result. So this result is like a named placeholder in the interface. We want to pull it from our API server that we created in the previous video. It's based on FastAPI. So I'm going to start the FastAPI server with FastAPI run. I'm going to specify the port 8080 because Shiny and FastAPI uses the same default port of 8000. And we're going to start the app API underscore main.py file. So now we've got the FastAPI server, not the Shiny server, running on port 8080. I'm going to set up a set of Python constants for the URL and the API endpoints. We first need the base API URL. When it's running locally, it's going to be on the local host. So I'm going to call it http://localhost, or you could do 127.0.0.1. I'm going to put a colon and have it be running on port 8080. So this is I'm going to use this to tell the Shiny client to go to this base URL at a specific API endpoint that I've defined in the FastAPI server. The analyze URL is going to be at /analyze, and the health URL is going to be at /health. I'm using the Python F string here so that I can switch in the variable base underscore API underscore URL so I don't have to type it in every time. I'm also going to change the local host to the actual deployed API server at the end of the video. If you want to quickly see what these API endpoints are, you can go to the FastAPI server at port 8080/docs, and it'll give you a listing of what the API endpoints are. So we've got 3 here, /health, /kith health check, that's for leap cell, and /analyze. We're only using the /health and the /analyze. If you don't have the /kith health check, there's no problem. The application will still run on leap cell. We need to use the HTTPX package in order to connect from the Shiny application to the API server. I'm going to use UV to add HTTPX. HTTPX is an asynchronous client, and it's generally similar to the very popular request package in Python to make HTTP requests. The primary difference is that HTTPX handles asynchronous communication. So I'm going to import HTTPX at the top of our Python application here. So we have the input, and we've specified our input button as analyze underscore BTN. So we can now use that first word should be if. We can now use an if statement to check on the input with this ID that we assigned to the button, analyze underscore button. And Shiny will increment this counter for the button. So if it's 0, it means that we haven't touched the button at all. Then we're going to return a blank string. The first time we go through the app, our results portion of the page will be blank. And now this is the climax of the video where we now are finally going to connect to the HTTP API server. We use the keyword async, and we're going to use with HTTPX that we just imported the async client. as client. So this with as is, it will automatically close the connection when we're done. So this is a Python structure here, with as client. And the client is, we're just calling it client. So we'll set up a response equals await. Make sure you use the await keyword because it's an asynchronous communication with the HTTP endpoint. Client.post. So client is, we just defined it. And post is the protocol. It's either get or post most of the time. Post has a JSON payload. So the payload, JSON equals that text, colon, and then we have the input text that we are getting from the text box. On the FastAPI server, we're using Pandantic to make sure that what we receive from the JSON payload is a string. I need to make the def result asynchronous, but on line 16, that doesn't need to be asynchronous. That's actually the app server for Shiny. And now we can convert the response into the Python data dictionary that .json parses it, and the output from the FastAPI server is a Python dictionary. So now we have the Python dictionary to work with. We can use the F strings with triple quotes to preserve the formatting. So we're going to have multiple lines in here, which is why we're using this triple quotes. And within the F string, we can put a variable. If we put the variable in curly brackets, so this piece of text will have original. And in the curly brackets, with the output to the screen, we're going to have the data. It's a dictionary. So we know that the key is original. And we can check the output of our FastAPI server if we don't know what the output is. So on our FastAPI server, there's an endpoint/docs, which is built into FastAPI. I'm going to input a piece of text in here for the demonstration. And we know that it's original uppercase length word underscore count is coming back from the API server. So these are the keys of the dictionary. Well, it's originally in JSON, but the .json will convert it into a dictionary so we can get it. And it appears to be working. So when we press the button, it does send the data over to the FastAPI server, and we do get the response. And we can nicely access the elements of the dictionary with the key using the standard way of Python to access the value from the key, which is just these square brackets, and then you have the name of the key in the quotes. And this is a simple example of text processing on the backend FastAPI server. It's just for education. It's just using the Python upper. So we could have done the processing within Shiny, but it's illustrative of this more advanced architecture if you have other things that you want to connect to FastAPI in the future. So it's a more scalable architecture that might fit into your organization. And we will continue to put the rest of the keys from the Python dictionary in here so we can get the output. So this is fantastic. We have a FastAPI server that's running locally. We built it in the previous video. And then we're using a Shiny application locally right now that can access the local FastAPI server and gives us the response, and it puts it back onto this nice web page using the Shiny components. I've deployed the application, FastAPI application, on a Python server prior to this video so that we can test the live server, the live Python API server. And we've structured our application in Shiny to make the change of the base API URL endpoint very easy. I'm going to comment out the one to use for testing. and then we will put in the live production URL here. It's on a free tier of LeapSale if you wanted to build it yourself. And you can actually imagine that you're in a team of people and you have some people working on the API server, you're working on the Shiny front end, and it's giving you a bunch of data, and you can make all your data analysis and then just have that one endpoint to the API team. So this is another reason why you might want to break up your application between a backend API server. Imagine that there's 10 other people, data analysts on your team. Some are using R, some are using Python, there may be some person using Plotly, but you're all accessing the same data source. But for your application, which is in Shiny, I've just typed on that posit publish button, the one that looks like an up arrow below the GitHub cat. I'm going to deploy it right here live. I've already created a free account on Posit Connect Cloud, so the deployment is quite easy. The only thing is that since I used UV, I don't have a requirements.txt file here, which the Posit Connect Cloud needs. So all I have to do is export the packages with UV in the requirements.txt format using the UV export command in the bottom pane of the window here, -- format space requirements.txt. I'm going to go no hashes to make the requirements.txt a bit more compact. -O will output to requirements.txt. I have it now. The Positron publisher makes it automatically checked. So it's going to upload it to the Posit Connect Cloud free tier. And away we go. The deployment is working very smooth, especially that Shiny is a fairly complex application, or the framework is. And boom, it's already up. This is in real time. I didn't cut the video. It's quite fast. We have our application up in production, connected to the production FastAPI server. And just like that, you're a full stack engineer and a data scientist. This is wonderful. If there's interest, drop me a comment and we'll make this into a course. Congratulations and have a great day.